Welcome everyone, I am Advait Joshi, and in this video we are going to see how to find out the region of convergence for right hand sided signal. First of all, we see what is region of convergence. Region of convergence. So what is region of convergence? Region of convergence, it is nothing but a range of complex variables S in the S plane for which Laplace transform is finite on convergent. Or in simple words, we can say that values of S for which the integral remains constant. Uh, what is a Laplace transform is the first part. Laplace transform is nothing but a transform which converts time domain signal into the complex frequency domain. If this is our signal x of t, then applying Laplace transform will give us a signal in complex frequency domain where S is equal to sigma plus j omega, where sigma is Napier frequency and this omega is radian frequency. So we'll see how to find out the region of convergence for the right hand sided signal. Now what is right hand sided signal? Any signal has two parts, the left part of the origin and right part of the origin. The right hand sided signal is the part which covers from the origin and the right side, and it is denoted by, it is nothing but a causal signal. Every causal signal is a right hand sided signal. That is x of t is defined as like this, for which time t is greater than or equal to 0. So let us take example of a signal x of t is equal to e raised to minus at u of t, where a is greater than 0 and t is greater than or equal to 0, which indicates that this signal is causal, that is right hand sided signal. As the time is greater than or equal to 0, u of t will be equal to 1 as this condition. Therefore, our x of t will become e raised to minus at as this. So what is Laplace transform's equation? It is nothing but x of s is equal to integration minus infinity to plus infinity e raised to minus st into our xt dt. So our we will apply Laplace transform on our signal. It will give us the signal in complex domain from minus infinity to plus infinity x of t e raised to minus st dt. So as we are considering time for greater than or equal to 0, this limits of integration will change also from 0 to infinity. Our x of t signal is now e raised to minus at into e raised to minus st dt. So we will take minus sign and this t common from 0 to infinity e raised to minus of s plus a into t dt. Now this is simple integration. After solving, what we get is s plus a on s plus a minus sign and the limits as it is. So further we take this outside of the bracket and will keep it aside from 0 to infinity. So this step, now the further step is now important in the calculation for ROC. If we are going to consider only the Laplace transform, then what we'll do is we'll simply put this substitute these values of the limits and we'll find out the value. But if we are going to consider the region of convergence, what we need to do is we need to replace this s by sigma plus j omega. This step is very important in the calculation for ROC. If we are going to consider only Laplace transform, this step is not important, but if this step is omitted, but if we are going to consider the region of convergence, that is abscissa of convergence, we need to find out the sigma c. The abscissa of convergence, if we need to find out, we should substitute this s by sigma plus j omega. We don't substitute this s from denominator, just we substitute the s from the power or numerator. So what we'll get is s plus a e raised to minus of sigma plus j omega plus a into t from 0 to infinity. Now what we'll do is we will separate out this j omega t and sigma plus a will separate it out. So e raised to minus of sigma plus a t multiplied by minus j omega t. Now we'll apply the limits in this equation. First of all, infinity multiplied by minus j omega infinity minus e raised to 0 into e raised to 0. What we are getting here now is minus sigma plus a infinity, so omega infinity minus, this will give us as 1. Now we should focus on this part. When a Laplace transform is finite or convergent, if and only if it is present in region of convergence. And what is the precondition? That this integration should give us some finite value, some constant value. When it is possible, now this has two conditions. This will give us either e raised to infinity or e raised to minus infinity. What e raised to infinity will give us is infinity, which is not finite. So this case is not desirable. Now consider this case, e raised to minus infinity. This gives us 0, which is finite. So this will work. Now how will we find out this 0? This part should give us some minus infinity. That minus sign and infinity are present there. So this sigma plus a part should bear us some positive value. This should give us some positive value. That is, sigma plus a should be greater than 0. Therefore, sigma must be greater than minus a. This sigma is also called as sigma c. Sigma should be greater than minus a. Therefore, sigma c is equal to minus a, and this is the abscissa of convergence. Now, to the right hand side of this abscissa of convergence, our transform is possible, it is finite, and it will give us some constant in finite value. So by solving this further, now we are considering this as minus infinity total. So s plus a e raised to minus infinity into e raised to minus infinity minus 1. So this will give us 0, and this will be minus 1 as it is. So minus 1 plus 1. Therefore, x of s is equal to 1 upon s plus a. So our signal's Laplace transform is 1 upon s plus a. Signal's abscissa of convergence is sigma c is equal to minus a. What this implies is, if this is the S-plane and this is the part A and this is part minus A, this is abscissa of convergence, and to the right hand side of this abscissa of convergence, this all part, in this part our Laplace transform is convergent, or it will give us the integration will give us finite values. So this is axis of convergence, and this is region of convergence, or ROC, for right hand sided signal. Thank you very much.